So here is the basic concept of business application. As we are doing profit maximization in the end of last unit, I actually stressed the importance of marginal value methods. Okay, and here I strongly recommend the marginal value methods as well. The reason for that is previously, as we did a univariate case, the profit function is pretty long itself because it includes two parts, the revenue part and the cost part. Here, when you have multiple independent variables, the profit function would only be longer. And in order to avoid mistake, it is more sensible for us to do marginal value methods so that you can break the hard question, one big comprehensive question, down into smaller pieces. Okay, so now let's look at this problem. We need to find, we're asked to find the profit maximizing prices and outputs for the multi-product monopolist with the following demand and cost functions. Okay, so I'm going to switch to my document camera to do this. So in this case, it is example 4 on page 5 of slides 5-2. So what we are told is P as a function of X is 92 minus 2X. P as a function of Y is 176 minus 5Y. Okay, in which X and Y are amounts, quantity, basically, of products. So now, different from what we learned in the last unit, what we have here is multiple products included. And the total cost is 3x squared plus xy plus 2y squared plus 424. So you can think this as a refinery or chemical, producing company, right? You can extract materials from crude oil to produce the gasoline, but also you can extract material to produce, say, plastics, right? So possibly these two costs could be interchangeable because you are able to make different things from the same raw material, right? So now, in order to do this, first we need to figure out revenue. So here is revenues, right? The total revenue of X now is price of X multiplied by the quantity of X, which is quantity of the first product, which is X. So that is 92 minus 2X multiplied by X. So that is the first revenue. The second revenue is the price of the second good multiplied by the quantity of the second good, which is Y itself. So that is 176 minus 5Y by Y. Okay, so those are the revenues. And here we also have costs. Then the second step to do is to find marginal values. Okay, marginal revenue of the first good is the derivative of the total revenue with respect to X. Right? And note that the actual total revenue in general, so previously I should erase this total revenue. So this is just revenue from good 1, revenue from good 2. The total revenue is Rx plus Ry, which is 92 minus 2x by x plus 176 minus 5y by y, okay, which is 92x minus 2x squared plus 176y minus 5y squared. So this entire thing is your total revenue. And here you want to find the marginal revenue, which means producing one additional unit of X, a good one, how much your total revenue would change. So here, take the derivative, partial derivative with respect to X, meaning you only view X as the variable. So the result is 92 minus 2 by 2x, which is 92 minus 4x. Okay, and marginal revenue with respect to y, this is the derivative of total revenue with respect to y. That is, the first two terms are disregarded because that's only x. And here we only view y as the derivative. That's 176 minus 5 by 2y, which is 176 minus 10y. Okay, that's the marginal revenue of y. So then we turn to the cost side. Marginal cost of x is the partial derivative of total cost with respect to x. Okay, that is 3 by 2x plus y. That's it. And then the other two terms has nothing to do with x. So it's 6x plus y. And the marginal cost of y is partial derivative total cost with respect to y. So that is x from this term, the first term disregard, plus 2 times of 2y. And the last term constant disregard. So it's x plus 4y. Okay, so that's step 2. And then step 3 is to match the corresponding marginal values so that you can solve for x and y respectively. So here we have marginal revenue of x, 92 minus 4x, equal to marginal cost of x, 6x plus y, and we have 176 minus 10y, that is the marginal revenue of y, equal to marginal cost of y, x plus 4y. Okay. Then we just need to solve this system equations. So before solving this, I'd like to explain to you why we are doing this again. So here, the reason for that is we are trying to find x that maximizes total revenue, right? And x that maximizes profit, I'm sorry, the entire profit. And here, profit equal to total revenue minus total cost. So this profit can be written as total revenue minus total cost derivative of x. Okay, that equal to partial derivative with respect to x of total revenue minus partial derivative with respect to y, x of total cost, which is marginal revenue minus marginal cost. Again, that equal to the right-hand side of the equation. Previously, we were merely working on expanding the profit function, right? So that equal to 0. So that's why we have marginal revenue with respect to x equal to marginal cost with respect to x. By moving minus marginal cost with respect to x to the other side of the equation. So that's why we have this kind of matching. You're having the marginal revenue of whatever equal to marginal cost of whatever. Okay, so now we have these two equations and we have two unknowns, x and y, we can solve them. So it's just a quick solution here, which is, so let me solve by hand here. And again, you can simplify this first and then use solver to do it. So let's simplify. The first one is 96 equal to 10x plus y. 10 is minus 4x, move to the other side is 4x. Let me write this step by step. So minus 4x, move to the other side, change into positive, plus the original 6x plus y, which are original on the right side of the equation. So it is 10x plus y. Okay, the second equation is 176 equal to minus 10y, move to the other side of the equation and change the sign, plus x plus 4y, which is x plus 14y. Then you can do replacement, right? So here, equation 1, equation 2 is actually x equal to 176 minus 14y, which is move 14y to the other side and change the sign. Then we have equation 3. We take equation 3 into equation 1 to replace x. We have, so that we have 92 equal to 10 times of 176 minus 14y, which is x now replaced with y plus y. So that is 1760 minus 140y plus y, which is 1760 minus 139y, right? And that is 139y equal to 1760 minus 92, which is 1668. It's minus 100 plus 8. Okay, then we divide 139 to both sides. We have y star equal to, we can solve for the y, equal to 12. Right? With y solved, then we can take this 4 into 3 to solve for x, which is x equal to 176 minus 14 by 12, which is supposed to be 8. So this is the entire process. I mean, the solution of this is just to solve system equation by hand. And later on, I will go over this with how to solve this system equation with Excel again. That's why in module 1, I specifically taught you with Excel solver to solve for system equations, because here we do have a good use of that.